Right, this is the final lesson here, 8.3. We're going to solve some problems using trigonometry. Alright, so we're not going to do part 2. It's more of the same, just quite a bit more complex. We're just going to do the problems here in part 1. So it says here we're looking for the pole CD, so this length here, okay, which is on the roof of a building. Use the diagram shown. So if you ever get a word problem that gives you a diagram, you should be very happy, because that's typically the hard part of word problems, is creating this diagram. Now you have it given to you here, so really that's the hardest part of a word problem, is really sort of putting the triangle together, the diagram. The angles of elevation, remember elevation are from the horizontal, so of AC, so this line is 55, and AD, A to D is 73, this line 73, and they already gave you the angle inside. You could have subtracted these two. I think that would have been more realistic, not giving you the 18, but 73 minus 55 is 18, gives you that inside angle. Okay? The distance AB is 35, so they give you this distance as well. Alright. So, if we want to know DC here, this length, we really want to work with this triangle here. Okay? If we can work with this triangle, if we can solve this triangle, we can get DC. Okay? So, what is this triangle, this little triangle here, and this right angle triangle, we know this is a right angle triangle, what do they have in common that we can work with? It's this side, right? If we can use SOHCAHTOA to get this side length, then we can use that side length in this triangle to find this side length, right? Using our sine ratio. That's the idea. That's the plan, anyways. Okay? So, anybody have any ideas with SOHCAHTOA of how we could get this side length here? Chenier, yeah. Sorry? Yeah, I'm asking you, so this is a right angle triangle, so we can use our SOHCAHTOA ratios. How would you get this side length?
The hypotenuse.
Yeah, it's the hypotenuse. So how would you get it? You can't use Pythagorean theorem, right? We're beyond that anyways, because we don't have this line. So we have a side and we have an angle, so how can we do it? Which ratio would you use? Sine, cos, or tan? Tan. Now if you use tan, you need both sides, not the hypotenuse, right? You could solve for this side, but that's not the side of interest. Jafet.
Use cos.
I'm going to use cos, yeah. So if we use cos, we're going to do adjacent over hypotenuse, right? That's why it's called co. So, it's called Ka, C-A-H, right? So we're going to use Ka, right? Cos equals adjacent over hypotenuse. So the cos of 55 degrees, this one, is going to be equal to adjacent 35 over this length here, okay, which we'll call h for now because it's the hypotenuse, right? Adjacent over hypotenuse. If we cross multiply this, we'll get h is equal to 35 over cos 55. Sorry? Lowercase d, sure. Yeah, it's opposite the d. I just called it h for the hypotenuse because I was working in this triangle. But yeah, if you want it in this triangle, call it d. Talking about what? Oh, it could be opposite this one. Usually, yeah, it really doesn't matter, Chenier. Like, it's just a variable, right? We can pick whatever we want. When you have two triangles overlapping, it's hard to say like which vertex is your opposite. Are you opposite D or are you opposite B, right? Depends what triangle you're working in, I guess. Anyways, doesn't really matter. It's going to give us the same answer. So we do 35 divided by cos 55.
joining us at the front entrance of the school to raise the pride flag. So please make your
Okay, so we got 61.02 meters, right? So this length here is 61.02. All right, that's this length. Okay. Now, what can we do to solve for this length, DC? Any ideas? We have an angle, we have a side. Can we get the other angle? Watch this, okay? I know you guys might not have seen this, but there's another triangle here, this big triangle, all the way here, which is going to help us out quite a bit. It's going to help us get this angle. Any ideas how? This big triangle. How can we get angle D? Yeah, Adrian.
90 plus, sorry, 180 minus 90 minus 55 minus 17.
Yep. That is equal to 17. Okay, so what we did here is we have both of these angles. We added them together, 73. Minus 90 and 73 from 180, we'll get this angle. So now we have angle D. We can use what? Yeah.
I have a question. Why do you use the 18 degrees?
Because it's in the big triangle, this big triangle. See this triangle here, Chenier? It's 18 plus 50. Yeah, you could have used just 73, but he decided to just subtract both of these. Jafet.
Oh, we can use tangents?
We can use tangent. What do you mean tangent? What? Like TOA?
Yeah, to find.
No, because it's not a right angle. To find this, you can't. You got to use sine law or cos law. Lucas, what do you think? Sine law or cos law? Not with us? Sorry? Yeah, sine. You're going to use sine law. If we ever have a choice between sine law and cos law, you're going to go with sine law. Why? Because it's so much easier. When do we have a choice with sine law? Well, when we have an angle and we have its opposing side, because then we have a full side length. Now, I'm not going to put the angle on top because we know we want to solve for a side. So what I'm going to do is put the side on top, right? So we're going to say 61.02 over sine 17 is equal to our unknown x over sine this angle, right? And we should know that angle because that angle is going to be 180 minus 18 minus 17, right? So 180 minus 18 minus 17. Any questions how we know this angle is 145? Sorry, not this angle. We want the opposite angle from CD. It's 18. My bad. I don't know why I was focusing on that. It's sine 18, right? This angle opposite. This side length. Okay? So now we can solve for x. I'm just going to multiply both sides by sine 18. So I'm going to say 61.02 times sine 18 divided by sine 17. We get x is equal to 64.493, so 64.5. All right, find the length of the flagpole. The flagpole is 64.5 meters. It's a very, very tall flagpole. It's like 180 feet high. More, 190. Okay. Any questions on this one? Looks complicated, but when you break it down into all the steps, pretty easy. Example 2. Julian stood at a distance admiring a magnificent Douglas fir, this big tree. Julian measured the angle of elevation to the top of the tree and found it to be 15. This angle here. This is Julian, by the way. I'm not sure why they didn't label it J. Jillian then walked 31.4 feet closer, so she walked towards the tree here. This time the angle of elevation to the top of the tree was 17. So this new angle, calculate the height of the tree to the nearest tenth of the meter. So we want this height right here. All right? Any ideas? We got a couple angles and we have our feet here. Okay? Let me ask you one question. Do we know this angle? If we did, we would have 3 angles on a triangle here. Do we know that angle? Yeah, what is it, KG? Yeah, it's 163. How'd you get that? Right, 180 minus 17. We know this by our angle law, right? Straight line is 180 minus the angle 17, we get 163. So if we have 163 and 15, we should be able to get this angle. It's going to be pretty small. 180 minus 15 minus 163. 2 degrees. Very small. All right. So now we have our 2-degree angle. What we can do here is we can draw a parallel line to the ground, and through our angle law, we can actually figure out what this angle is. Now, if we get this angle, then we can figure out the angle in our big triangle. Sorry?
Instead of doing that, can you just do 180 plus 50? Sorry, you could do 180 minus 90 minus 15 minus 12.
Sorry, you talking about this angle?
Yeah.
Yeah, you're right. You could just do 180 minus 90 minus 17. So we'll get what? 73. Yeah, you're right. 73 degrees. Okay, so now we have...
College are proud to celebrate Pride Month. This June is a chance for our school to demonstrate our commitment